Hello everyone. Today we are going to discuss a few problems related to Kishore Vaigyanik Protsahan Yojana that is conducted every year, K.V.P.Y, and these problems will help one to understand it or attempt the questions in a better way. So the first problem being uh, we have rigid support, right? And from that rigid support, two masses two masses are suspended such that they have different masses. The radius of those spherical masses being the same, that is r. It is let's take it as capital R for each, and the length of the string from which they are suspended from a common point, let that be L as well. So now in equilibrium condition, the masses being different, obviously the center of mass is shifted away from the center. We need to find the angle theta that the second mass makes with respect to the vertical line. Okay, so we need to consider the center of mass, and we'll be getting the position of the center of mass, and that position will help us to determine theta. Now in order to obtain that center of mass position, let me consider the diagram once again. So we have the masses over there, that is the distance between them uh, is obviously the radius, twice the radius, and let that base be equal to d, that is the distance, the horizontal distance of the second mass from the center of mass, the point where we are considering the center of mass to be, and the radius is such that it is very less than the length of the string from which it is suspended. Now consider the center of mass, determination of the center of mass in those two mass system. So m1 and m2 are the two masses. The first one is m1 and there it is m2, and in those two point mass system or two mass system, we have them to be separated by a certain distance. That distance obviously here is 2r, because the radius of each sphere is r, so they are separated by a distance of r plus r, that is equal to 2r. And r1 and r2 there that I have considered are the position vectors. Now this is a simple diagram showing the center of mass, and rcm is the position of the center of mass, position vector of the center of mass with respect to the origin that has been considered in that frame. Now how to determine that rcm? We know that value of rcm vector is equal to m1 r1 plus m2 r2 divided by m1 plus m2. This is the formula that we have for the center of mass, the position vector of the center of mass. So again, going back to the sketch or the free diagram that I have considered over there, m1 and m2, and the point from the center of mass is the distance d that we need to consider. Yes, so I have taken the value d in both the figures that I have drawn. So d vector is directed towards the center of mass from the mass m2. Now rcm vector is equal to r2 vector plus d vector. Now consider the triangle law in that small triangle that we have for the second mass with the center of mass and the origin. So d vector will be simply equal to d vector is equal to rcm vector minus r2 vector. So this is vectorially we have from the triangle of the previous equation, and then from that equation we have the equation for d vector. Now that will imply that d vector is equal to, we put the value of rcm that we have obtained, the position vector rcm, and so we put that value m1 r1 vector plus m2 r2 vector divided by m1 plus m2, that is for RCM that we have used over there. Yes, that is RCM. And then minus R2 vector. Now this equates to, with m1 and m2 as the LCM, we take m1 vector, m1 r1 vector plus m2 r2 vector, and then we take the LCM as m1 and m2, m1 plus m2 as the LCM. So from that we multiply m1 and m2, m1 plus m2 with r2 vector, and that whole divided by m1 plus m2. Now we just multiply r2 vector with m1 and m2, that is within the brackets. I write it up there. That is m1 r1 vector that we had previously for RCM plus m2 r2 vector minus m1 r2 vector, and then we have minus m2 r2 vector, that whole divided by m1 plus m2. Now the obviously you can see that m2 r2 vector gets cancelled for the positive and the negative parts, and all we are left with is a d vector is equal to m1 taken common for both the terms that are available, m1 whole multiplied with r1 vector minus r2 vector whole divided by m1 plus m2. Now as you can see, r1 minus r2 vector, from the position vectors that we have over there, we can write d mod is equal to the modulus, that is the magnitude of d, is equal to m1, and we take the magnitude of r1 minus r2, so r1 vector minus r2 vector, the modulus of that gives me the magnitude, so, and then divided by m1 plus m2. So this is the modulus of d, or the magnitude of d we have over there. Okay, so now we have the magnitude of d. Now r1 and r2 vectors are the position vectors, so r1 minus r2, in between them we have the length 2r, so again we will apply triangle law for that complete set of triangle having the position vectors r1, r2 and 2r. So we have r2 vector plus 2r vector, which is 2r is directed from m2 towards m1, so r2 vector plus 2r vector is equal to r1 vector. So we have r1 vector minus r2 vector is equal to 2r vector. So r1 minus r2 mod gives me 2r. So this value of d, that is the modulus, is equal to 2r times of m1, 2r substituted for r1 minus r2 mod, whole divided by m1 plus m2. So we have the value of d as of now. Now as we can see, theta, the angle, that is very small, so for smaller angles we can write the value of theta, or L times of theta, that L acts as the radius and theta is the angle, is equal to the arc length d. So we have theta is equal to d divided by L. Now we have just substitute the value of d that we have obtained, the modulus of d. So we have theta be equal to the value of d, that is 2, we can rearrange that, 2 m1 into r divided by m1 plus m2, that whole divided by L, or we can just put it in a better way, that is the required value of theta. We can just remove the brackets over there and just leave the brackets in the denominator. So we have 2 m1r whole divided by m1 plus m2 whole into L. Now the second question has a uniform plates. Okay, it has two uniform plates of same thickness and area, but of different materials. So the area is same, that is to be noticed, and thickness is same, so obviously the volume will be same. So they are arranged in such a way such that the center of mass of the composite system that has been given, the composite system of triangle and the rectangle. Okay, so the center of mass of the composite system lies exactly at the midpoint of the line common to both the figures. Okay, so it lies at the midpoint of the common side of both the composite system, comprising of the triangle as well as the rectangle. Now we need to find the ratio of the masses. Now m1 is the mass of the triangle and m2 is the mass of the rectangle. They are of different materials, obviously, so they will have different masses even if they have the same volume. So with the area being same, we are not concerned about thickness now. Only thing that can change is the area, and because of that the volume will change. So for same area we'll be having let's take the height of the triangle to be h, and the that is the breadth to be b for the rectangle, and the length of the rectangle to be equal to L, right? Length L, breadth B, and then we have the diagonals. Okay, so the top surface is also L, the common side. The length of the common side is L. Now the area of the rectangle is half of the triangle is half of the base, and the base is the same as the length of the rectangle, so half of L times of h, and that will be equal to the area of the rectangle, that is L into B. So L's cancel out on both the sides, so we have the breadth of the rectangle to be equal to half the height of the triangle. Okay, so this is the relation between the dimensions given. Now the center of masses, the center of masses of both the figures of the triangle is at the point C1, which is the centroid of the triangle, and that of the rectangle is at the point C2, which is at the intersection of the diagonals. Now as we know that this centroid, it lies at a distance of one third the height of the triangle, height that is h we have taken, and the diagonals obviously bisect at the midpoint, or exactly at the center of the rectangle, that is at a distance of half the breadth, or as the breadth is half of the height of the triangle, so we have that value to be h by 4. Now from as we can see that the midpoint lies along the line of C1 and C2, the moment of mass about that midpoint of that common side, the moment of mass of the system about that midpoint, okay, about that midpoint over there, because that lies in the line of C1 and C2, that point, let it be P, that will be equal to 0. The moment of mass has to be 0 about the center of mass for a given system. So what we have over here is the moment of mass is mass times the distance from the center of mass. So m1 times of the first distance, that is of the triangle with respect to the center of mass, that is h by 3, and m2, the distance being h by 4, as we've obtained earlier. So the h can get cancelled out, and that will imply m1 by m2, that is the ratio of the masses, that will be equal to 3 by 4 by means of cross multiplication. So that is the ratio of the masses of the composite system. Now in case of the third example that we have over here, we have a person to be standing at the top of a tower which is 85 meters in height from the ground level. Okay, so that is the ground level, and 85 meters in height, and he throws a ball, okay, or anything, a solid object which goes up and then comes down, and as it strikes the ground, thereafter he hears the sound after 5.25 seconds. Okay, so 5.25 seconds later is the time from the point of release from his hands in the upward direction. We need to find the speed with which he had projected the object in the upward direction, and let that be u. So we need to find the value of u, the magnitude of u, and the velocity of sound for the given medium is 340 meters per second. So this is what we have, and also we have the value of acceleration due to gravity in that case to be equal to 10 meter per second square. So with all these information available, we need to obtain the value of u. Now, as he the point from when he hears the sound, as the velocity of sound in the given medium is 340 meters per second, so by the time it reaches or it strikes the ground, from there it has to travel a distance of 85 meters up to that person, right? So 85 meters is the distance traveled by the sound after the object hits the ground. So the time taken in doing so is distance divided by the speed, that is 85 by 340, and that cancels out to give me 1 by 4, or 1/4 of a second, which is equal to 0.25 seconds. Now remember, he hears the sound 5 seconds later, 5.25 seconds later, so all that is left now is 5 seconds. So 5 seconds is the time, after we get rid of that 0.25, 5 seconds is the time it has gone up and it has come down, right? And thereafter, after coming down, he hears the sound in the rest 0.25 seconds, so that adds up to 5.25 seconds. So with 5 seconds, the time interval that the object goes up and comes down, that is the for the net displacement, the time is 5 seconds, okay, from the top to the bottom. And the net displacement obviously is 85 meters in the downward direction. Okay, that is why it is negative. With the velocity considered in the upward direction to be positive, the displacement obviously is in the downward direction will be negative. So there is 85 but minus of 85, right, as u is positive in the upward direction, as simple as that. And also for that we will have the acceleration due to gravity, that has to be considered negative as well, because the acceleration due to gravity acts in the downward direction, which is pulling the object in the downward direction, and that is why the acceleration has to be negative when we are considering the upward direction to be in the positive frame. So as we have from the equation of motion, that is s is equal to ut plus half at squared, so we just substitute the values now. So for the displacement, that is s, we have the value to be minus 85. The displacement that is in the downward direction, that is minus 85 meters, and then that will be equal to u, that has to be obtained, and t is the time, that is 5 seconds for the complete journey from the release to the point it strikes the ground, and acceleration due to gravity is negative of 10 times of the time is 5 squared. So ut plus half at squared is what we have obtained in the equation. So minus 85 that we have over there is equal to 5u. You can write that as 5u. Half gets cancelled with 10 and multiplies with 5 squared, that gives me minus of 125. Minus goes to the other side, so we have 5u to be equal to minus 125 goes to the other side, so plus 25 plus 125 minus 85 gives me plus 40. So u is equal to 40 by 5, that is equal to 8 meters per second. So that is our answer. Okay, so that's all for today. Till next time, thanks for watching.